Hey guys, I'm going to go ahead and run you through how to find the second derivative when dealing with parametrics. And if I have time, I'll try to go back and show the first derivative again like we did in class. But we did figure this out in class, that dy dx is dy dt divided by dx dt. Okay, so we have the first derivative. This will give us slope. This will be able to get us our tangent lines, all the usual stuff that a first derivative would get for us. But this is in terms, when x is in terms of t and y is in terms of t. This was the example from class, I believe. And you can literally do each one of these individually, dx dt, dy dt, and we can figure out what our derivative is. So that'll give us horizontal tangents, vertical tangents, things like that. But then we said, okay, what about the second derivative? So the second derivative is the derivative of dy dx, right? So the derivative of dy dx is the derivative of dy dx with respect to x. Okay, so I'm taking dy dx prime essentially. So the derivative of dy dx, so the derivative of dy dx with respect to x. Okay, and I know what you're thinking. It makes sense, to initially think that, oh, just do this one more time. Do the second derivative here, do the second derivative here, and you're good to go. But unfortunately, as I'll prove to you, it doesn't work that way. So dy dx, we know, is dy dt over dx dt. Right? And that's still over dx. So I know this is my dy dx, so I'm basically just substituting that in here for there. And now I'm just going to manipulate this a little bit. So this is d dx for dy dt over dx dt. So I did a little maneuvering. So this right here, the d dx is right here. That's this. And then I still have dy dt here, and I have dx dt here. Okay? Now, because this is, these are both in the denominator here, I can just switch these out. This is going to be d dt dy dx over dx dt. So this is the derivative of dy dx with respect to t. Okay? So I can actually take the derivative of dy dx just like you wanted to here when you wanted to do a second, but I still have a dx dt component to deal with. Clean that up one last time. Dy dt over dx dt all over dx dt. And now everything is in terms of t. Right? The derivative of dy dt over dx dt with respect to t divided by dx dt. All right, so let's do this out. Sometimes you'll see it both ways here, but this is essentially what you've got to deal with. I'll just leave it like this. Okay? So if x is t squared, then dx dt is 2t. dy dt is 3t squared minus 3. Okay? So dy dx is going to be dy dt over dx dt. And we did this in class, so this part was already done. There's your dy dx. To find my second derivative, I'm going to take the derivative of dy dx with respect to t, okay, which is, it's already here. I've already done all this work. It's really right there. And I'm going to put that in. So my second derivative, my d squared y over my d squared y over dx squared is going to be the derivative of this. So I'll write it with one step here. 3t squared minus 3 over 2t prime over, right, dx dt. Well, dx dt is just 2t. So now here I got to take a derivative. Now I could do a quotient rule. I could split this up, whatever's easier. But I am going to need to go ahead and take that derivative. So I think most people probably would look at this and say, oh, I should do a quotient rule. So I'm going to actually do a quotient rule and go from there. Let me start on a fresh piece here. I'm just going to copy it real quick. So d squared y over dx squared is 3t squared minus 3 over 2t prime over 2t. Okay? So that's this. I've just recopied this on a fresh sheet. Okay, the derivative of this over 2t. So here we go. So this is going to be quotient rule. Square the denominator. leave the denominator alone. Derivative of the numerator, which is 6t, minus, leave the numerator alone, times the derivative of the denominator, which is 2. Okay, wow, that came out really messy. Let me do that one more time. I'm sorry. 2t, I'm rushing because I know you really need this for tonight's homework. So 2t, right, leave the bottom alone. Derivative of the numerator is 6t, minus, leave the numerator alone, 3t squared minus 3 times the derivative of the denominator, which is 2. All over the square of the denominator. And that is my prime of dy dx. Right? My original. I still have to divide that by dx dt. Okay, so let's match things up. Ready? So, derivative of dy dx with respect to t is this whole thing, that quotient rule, divided by dx dt. And that was the original dx dt from the very beginning of, when x was t squared. Dx dt was 2t. Now we just got to clean this up a little bit. It's actually not as bad as it looks. I know it looks bad, but it ends up not being terrible. 12t squared minus... Oh, one sec. Okay, sorry about that. The doorbell rang. So cleaning this up, 12t squared minus 6t squared plus 6, right? Minus 6 here times negative is positive 6. All over, well, I have 2t squared here, and I have a 2t here. That's really 2t cubed. So this is 6t squared plus 6 over 2t cubed. Let's take out the 6. T squared plus 1. This is really 8t cubed. So that's 3. What's that? 3/4. 3/4. So 3t squared plus 1 over 4t cubed. And there's our second derivative. And if I remember right, I think the question asked about concavity, something about concavity. So we can look for our critical numbers. It looks like t is 0 is a critical number. So at t equals 0, if I make a number line just like the olden days. Right, so this is d squared y over dx squared. T equals 0, critical number. When t is negative, this whole thing is negative, positive. So it looks like concave up, t greater than 0. All the same stuff we've learned before. It's just a matter of applying it using parametrics instead. Okay, so again, formula you need to help you with this is basically, it's really this one. That's probably the one you'll see the most often. The derivative of dy dx with respect to t over dx dt. Okay, but it all comes from this, which we already did. Alright, that should help you finish the problems. If you need any more help, please ask. I will be happy to do whatever else I can do to help you out. But I think that's good enough. Okay? Alright, I'll talk to you guys later. Good luck.